Where's the boss? All right. All right. Hi. I'm Brad Fitzpatrick. I will be giving this talk along with Matthew. I work on the Go team at Google. This is my kind of side project. This is what got me into Go originally. I don't know if you want to introduce yourself, Matthew.
I'm just his faithful assistant.
Faithful assistant. Do we have a microphone for Matthew? Okay.
No.
You'll come over here. Okay. So Camlistore has been open source about almost 4 years now, and we don't really have a great description of it, but we've been saying it's a way to store, sync, share, and model and backup content, which I guess will make more sense when we're done here. Kind of more background is I've written too many freaking CMS systems, and I'm kind of sick and bored of writing them, so I thought I would write one last content management system, kind of rule them all, and you'll see if that happens. But I wrote LiveJournal back in the day, and that was a blogging CMS and had comments, and then I built my own photo management thingies and back up my emails, and I wrote my own backup software, and I have a little thing to scan all my documents. But sometimes something you scan is also a photo, it's also a blog post, and I'm kind of sick of thinking about like what the thing is. I just want a place to put stuff, and I don't really like file systems, and I just wanted like kind of a dumping ground to build CMSs. I don't really trust any company in particular. I like protocols and standards, and I'm sure you guys are all dorks and kind of agree with us. I don't mind people running hosted versions of things as long as it's a hosted version of some protocol, and I can migrate away to somebody else later. So I wanted a storage system that would outlast me. I wanted a system that I could trust would be here in a number of years. I trust some companies today, but I don't trust them in 20 years. Like Google, I think is awesome today, but I don't know what Google will be like in 50 years, and I want my data somewhere. And I'm going to be like old and tired of migrating data by then, so I want something that I'm in control of and I can trust will survive. I'm also disturbed by this increasing merge of companies that are your tool provider and they're also your storage provider. It's like if I wanted to build a desk, I needed some wood or a bed or a desk. I would buy some wood from somebody, I would buy some tools like a saw from somebody else, and I would make my thing and then I would have it. Or like, when computers first came out, you would build a computer and you'd buy a hard drive and you'd buy Photoshop or, whatever. Like maybe you buy some tool and you would create some document or some photo and you would store it on your hard drive and you would have the storage. And increasingly with the cloud, which is, great and all, the person who supplies your tool, whether it's like Facebook or, Instagram or something, are also the people that hold your storage. So this is also a project to separate out the roles and to be the storage part. So I wanted something simple, cheap, reliable, that will survive past me, and I don't want to worry about things. I don't want to worry about like sync and conflicts. I don't want to worry about companies failing. I don't want to worry about me messing up. It should be like low stress, basically. I also care about data archaeology in terms of I have data that I can't get back because it's on some weird disk or in some weird format. And so I want something that will be easy to understand, generations from now. So Camlistore is a big private dumping ground for all your stuff. Think of it as kind of maybe like a Git repo for your whole life, but more flexible than Git in a lot of ways. And so it can do backups, file systems, but it can also store things that aren't files. So you could just store like, a like on a website, or maybe a copy of every web page you read, or photos that don't really have a file name. They're just a photo, or basically everything you make, everything you produce on the web, all your kind of byproducts, everything you read, maybe everywhere you go on your phone, your live location, like keep your own copy of stuff, even if it's not necessarily hosted on your own server. It could be encrypted and stored on, any other 2 companies you trust today. Make sure that you always trust 2 companies. If one fails, you just find a second company or friends or spray it across the web. So there's the web UI, which I'll show you. There's a Fuse interface. There's command line tools. And it's supposed to be, usable by my parents and my friends and stuff. And, dorks like you guys, that's a compliment. So the security model is everything's private. You can kind of think of it as like your Gmail, but, where your Gmail is just your email, this is all your stuff, which, can include your email. and your photos and whatever. And if you want to share it with somebody, you can share it with somebody, or some subset of it rather. But by default, you just put stuff in it and you don't really worry about it because only you can access it. The name was supposed to be temporary. It's been 4 years now and we haven't found a better name. But this was the directory that I started hacking on this thing. It was content addressable multi-level index storage, which we'll walk through. Everyone I think here probably knows the advantages of content addressability. Things I like, that you can sync every which way and you don't have to worry about conflicts because there are no versions of anything. It's just the frickin' data. Any sort of merge resolution or like whatever diffing and blah, blah, blah happens at higher semantic layers in the stack, but at the raw, boring base layer, it's just chunks of stuff, some bytes. We can verify things and dedupe things and blah, blah, blah. The multi-level part of the name, Camlistore, comes from that the base level is just blob storage, and then there's an indexing system on top of that makes sense of all the blobs. There's a search layer that uses the index and lets you ask any arbitrary questions about finding your stuff back. And then there's a bunch of interfaces to it, whether it's the web UI or Fuse or command line tools, that are clients of the search system and the blob storage. So logically, it looks something like this. That you kind of have your front-end server, and then there's a search and indexer, and then your index storage is just on anything basically, and your blob server, which stores the blobs on basically anything. And you can run multiple blob servers in different places, and I do, and sync them all. But this is like actually one piece, one process, one Go binary. But you would expose it to the web, so you can access it, and it deals with authentication here. And you could sync to other people's servers, some subset of your stuff. But in reality, some users would just go to some website and use some hosted version, and you guys would just run your own binary probably. So we're going to walk through from the bottom up. The blob server, we'll be showing a bunch of demos in a bit, but I want to kind of explain what the base operations are. A blob is just 0 to 16 meg. There's some justification for 16 meg, but in practice, the blobs are actually like 16 to 256K about, and sometimes they're 100 bytes or so for like tiny little metadata things. The basic verbs you can do: get, put, stat. You can enumerate them all, and there's the HTTP interface. There's really no delete. There's delete that's implemented there, but it's only used by the garbage collector. So basically, you never can lose anything. You just put stuff in, and if you delete something, that's just a request to delete something, and maybe it disappears, like you delete it in your file system, and sure, it's gone, but you can just go back and look at an earlier version of time, and it's still there. You can actually delete something if you want to claim it's deleted and wait for the garbage collector, blah, blah, blah. But, so at this level, at the blob server, there's no metadata at all. There's no file names, no MIME types, no access times or mod times or anything. The size is implicit just on the, the number of bytes in it, and any other metadata you might want is at layers above this in how we model the data that goes into the blobs. So we're going to do some demos. You want to explain some of this?
So, as he said, everything in Camlistore is stored as blobs. So what we're going to do is first play with blobs and inspect.
Could you please speak up?
Yes.
Yeah,
Speak up and be near this, I guess.
Okay. So we'll start by inspecting some of these blobs. And Brad has just started a Camlistore server. So the first thing we want to do, we are going to enumerate all the blobs which are on this server. And we're going to use one of the command line tools of Camlistore, which is CamTool, which is kind of a Swiss Army knife for everything we couldn't put a place on. And it has this subcommand list. And as you can see, nothing is enumerated because we have no blobs on the server yet. So the second thing we're going to do is to create a blob. And for that, we have this tool called CamPut, which, as you probably guessed, is to push a lot of things to your server. It has a lot of different nodes as well. And we're going to start with creating a blob, like this, with the command CamPut blob. So Brad is going to create one from the command line. And so this foo blob was uploaded to your server. Now, how do we know that? First, you can do CamTool list again. And we can see that we indeed have a new blob with a blob ref on your server. And we can now use a third tool, which is called CamGet, which of course does the opposite of CamPut, and you can get your blob from your server, and you see that the contents of this blob is indeed this foo string. And now we can do it again with the same contents. And you can see that if you, no files here, yeah, you forgot it. You can see that if it does come to the list again, we still have only have one block because it was the same.
We can't hear you.
Sorry?
We can't hear you.
Yeah, sorry. My vocal cords are weak. Yeah, so you can see that no other blob was uploaded because it was the same contents. Now we could retry with a different blob, of course. And you can see a second one, which we could again get with camget and get the same context. So probably now the second thing you want to do is to push files, right? Because that's what you manipulate every day. So now we're going to use another command of campush, which is campush file. And we want to push this readme file to your Camlistore server. So we use campush file. And again, if we list all the blobs, we can see that you should have 2 new blobs, right? So Brad, could you inspect those blobs for me? Could you get one of them?
So notice that the README file here is 586 bytes. So you could probably guess that this blob is the README file. But this little guy, the 322 byte one, is what was actually returned from camplet file, which is this 9851. If we get that guy,
you can see that it's a bunch of JSON metadata with different values, and you have the file name of the file we just uploaded, and below it are all the parts, for the contents of that file. And since this README is really small, it fits in only one blob, which is the blob that Brad just mentioned before, which should contain the contents of the README. Okay? And as with blob, you can see that if we repeat the same thing with the same file, nothing changes. We still have the same number of blobs on your blob server, of course. And we could now try to upload a new one, for example, a different file or a directory. Yeah, we could upload a new directory, the tag directory, and
which is a bunch of stuff.
And you can now inspect all the you can get it. And again, you can see that it has a different sort of key values. One of them says that it is a directory with this Camlistore type, that is the main one. And you can see all the different entries of that directory in this blob here, all the members of that directory. And again, so now what you may or may not know is that blobs are immutable, right? So if we were to change something, if you upload, it's always the same thing. But now if we were to change something in the directory, the file, for example, create a new file, it will of course upload a new blob for that file. And the thing here is that since you have new blobs, you could not just with blob keep track of the latest version of your directory, and you want to do that. So that is where permanodes come into play. That is the way we model permalinks, permanent reference to the stuff we push on our server. And we're now going to play with permanodes a bit, I guess.
I guess I'll talk about permanodes a bit before we do a couple more demos about them. So yeah, early on in the project, we didn't really, we were stuck for a while on solving this problem of we wanted the base layer really simple. Like in Git, you have the content addressable part of Git, but then you also have Git refs, which is kind of this like thing on the side, which is this other data structure that maps from a ref to what it currently is. And we kind of wanted that all in the same system. We didn't want to have this like 2 storage systems. We wanted just the blobs. So what we came up with is we make this thing called the permanode, which is just an immutable handle of an idea of an object, and itself it's just a tiny blob. We'll show you what it looks like. And then anytime we want to like modify it somehow, like add the data model, a permanode is just a key value, and every key can have 1 or more values, and it's just a convention based on the application that's creating these objects, these permanodes, about whether they use single or multi-valued attributes. Like a tag is multi-valued, but like a title, there's only one title, but there can be multiple tags and all this. And every time you mutate this, add or remove an attribute, it's just a new blob itself, a new claim. And all these things are, signed, and you could verify who made them and stuff. So
we're now going to see another mode of campush, which is to create a simple permanode, the basic one. So as you can see, we have a new blob. We can get it and examine it.
Yeah. So yeah, every time you run permanode, you get a new thing.
And again, you see it's a simple JSON schema with Camlistore, set by random, which is like a random string that helps with the signing. And we can see, of course, the Camli type. And this interesting part, the Camli signer, is your GPG key. You can see that you already had it on your server because Camput uploaded it's a detail. So this is your GPG key that is used to sign everything in Camlistore.
And you don't have to like go to a signing party and like set this up and like create a key. It'll create an identity for you. There's like a camput init or something, like a command that creates your key files and all this stuff. So.
All right. So now what we want to do is to associate a file to this permanent. So we can.
Let's just do some simple attributes first.
Okay. So yeah, the way we model mutations, we can examine here that it has this permanent has no attributes.
So camtool describe is another camtool command that issues a search query. And so we just created this permanode. And the search system, the indexing and search has found out that it's a permanode. This size is useless. That's just the size of the blob that says it's permanode. Here is when this permanode was last modified, which is never. And here's the current attributes. But we can start making some attributes. Say the title is hello. And we could do describe it, and we see that title's hello. We could put live demo, add awesome. And so now this permanode has attribute live demo and awesome, and it has title hello. And we could list all the claims that it has. And these are all the claims that contributed to its current state. And you can see there was a set attribute at this time, setting the title, set attribute live demo, and awesome. And each one of those has a blob ref. If we get one of those, whoops, you can see that the claim type, or the Camli type is claim. So it's a modification of a permanode. The claim type is adding an attribute as opposed to, just appending a new one as opposed to clearing its current state. The value is this. This is the permanode we're modifying. But should we, I guess make a.
I guess you could show the claims. We can get the contents of the claim themselves.
Well, this is one.
Yeah. Okay.
So, let's put a directory. So before, when we did camput file doc, we just got the same thing every time. Now we could also say, I also want you to associate a permanode with that thing. And now we get some different things. That's actually the permanode about it. And if we go into the little web UI now, you can see that there's that doc directory that I just put. And this was the permanode. I could also do things like camput, adder that, and change the title to hello. And you see that it was changing live there. So I could also, camput file, I don't know. What am I gonna do? And so, images and all that sort of stuff. So when I made this doc directory here, which I guess I now renamed to be that ugly thing, the blobs actually look something like this. You saw before the directory schema blob, which references, static sets, which have file schema blobs, which are, the JSON thingies. And eventually at the bottom at the leaves, we see the actual bytes. The permanode, so these things kind of like the arrows point down, and the directory references files, and the files references that. The permanodes, the arrows kind of go back the opposite direction. The permanode itself, remember, was just a random number that was signed. And all these mutations were their own blobs that reference the permanode. And it's the indexer that logically says these are all related because they all reference the same permanode. And this is kind of logically the object. And this one, this set attribute Camli content, pointed to that guy. So when I did that and set it to this file and uploaded that one, if I do camtool describe on that, I actually see that has an attribute Camli content pointing to that. And if I describe that thing, it's just a file that happens to be a JPEG and has these dimensions and all that stuff, and the indexer picked up all that.
Was any of this based off your Mongo FS stuff at Bangor, or it's all?
This is related. The question was, is this related to the Mongo FS stuff? And yes, I mean, that was one of the too many CMS's file systems that I've worked on, and that had some good properties, and it was also a pain in the ass in a lot of ways. So, I guess we'll just go into the rest of the stuff. So the two main abstractions inside the Camlistore codebase is the blob storage and the key value. The blob storage is, like I showed before, you just get set content addressable blobs from, I guess it's actually 0 bytes to 16 meg. In practice, they're about that size, and it can enumerate things. So we have implementations for the file system, like just your local POSIX file system, a raw block device, S3, Google Storage, Google Drive, WeedFS, App Engine, whatever. These things are easy to write, and people keep contributing them. The other abstraction is anything that can do sorted key value pairs. So where the keys and values are like, probably 250 bytes or less or something like that. And you have to be able to enumerate them in sorted order and do a commit of like an atomic set of multiple keys at once. And this is what is used by the indexing system, has some key value store. And basically anything that can sort has an implementation. So all the SQL thingies, Mongo, LevelDB. The default one that we ship is this one, Sysnic KV. And Dynamo, App Engine, blah, blah, blah. And so the interfaces for that is pretty small Go interfaces. Anything that's a blob storage is something that can, stream, receive, stat, enumerate, remove, and these are just small little interfaces. Streaming fetcher is something that can fetch, return a read, close, and resize. The sorted interface is just something that can get, set, make a batch, enumerate with an iterator, and return something that can set the things. So we have implementations for all that stuff. We also have the beginnings of import and export stuff, so we can import from web services, like import from Flickr, and model the data how you had Flickr and don't lose any of the properties from there, but map it to the common properties, including like importing your Flickr sets and stuff, importing your Foursquare check-ins, stuff like that. So these are kind of underway, and if you want to help out, writing these would be helpful. We deal with big files fine. We do this rolling checksum thing that goes over the file. So even if the file is like petabyte and shifts around by a byte or two or something, which doesn't really happen, but like imagine it's a JPEG with an EXIF header that kind of changes in size, or an ID3 v1 tag that you change the some metadata about it and the file shifts. You don't re-upload the 3 meg of music bytes in the middle. It has a little window that goes over the file and finds good cut points, and then makes like a balanced tree of the chunks to upload. So you can put in virtual machine images in it and fine, and all the chunks in the middle are deduped. We have a fused file system that is like, unlike Dropbox and Google Drive and stuff, it's actually a proper file system. So it's not actually just running rsync in the background and copying things to your local disk. It faults things in and caches it on the fly. So you can have a petabyte file that's logically there and go seek out and find a chunk in the middle, and it's fine and it works. So I guess we can show some fused stuff. What did we do before? What is this? Where'd that go? Let's just show something more fun. I will show that in a second. So we have a web UI. You saw this before, but that's kind of boring. I'll show my personal one, which these are pictures from the last few days, and so we have this infinite scroll thing going on here. That was a good pic from a museum, and babies getting cut. Some shoes. That's our little piggy. That's our loading thingy. This is coming from my house in California. So anyway, there's all this stuff, and then there's let me make sure I'm not getting too far ahead of myself. I don't care. There's a search system, so I can say find things in Amsterdam or whatever, and find things from Amsterdam, or I can say tag ADG, and then find pictures of Andrew, or like, location Paris is portrait, and find the stereotypical pictures of the Eiffel Tower. Or I can say, is pano, and find all panoramic photos. You can search for like EXIF fields and ID3 metadata things, or you can say it's like, it's not an image, not is image, and find things that are, not just photos. Or you can say it is an image, but it's not a JPEG, and find like random screenshots and stuff like that. You can do, various intersections and whatever. So I like live demos, so let's try something here. See if this works. Everyone smile. Okay, so we have an Android client and we have an iPhone client, and I will upload this, and you can't really see it, but it's uploading and connecting. We have this great debug UI that shows you all your stats and stuff.
So you have you can have them automatically upload as well. You can do it at demand, or
Yeah, you can see a little progress bar uploading the chunks. And this is being live replicated to my house and S3, and it's not acknowledging the writes back to the phone until it's on all of them. So, what process ended? Oh, did I hit? Sometimes live demos work. Yay! So, all the search queries are running live on the server, and whenever it receives a new blob that could have potentially affected the server or the search is rerun, and if there's any difference, it pushes the delta live to the WebSocket thing. So this even works on arbitrary expressions. If I could say like, for instance, okay, let's take the address of this and let's search for tag live demo. And so here's other times I've done this, but let's add this photo to the set. So here's my machine at home. I could say cam put adder. Oh yeah, the URL was. Let's go find this thing. We could do it the boring way and use the web UI to add it, but let's show command line tools. Okay, so here's the search. Cam put adder tag live demo, and it showed up there. So any search you do is live. Anyway, so the web UI has search. The command line also has search. The things you saw me typing were these little like one-liner things, so like is image minus format JPEG. There's a layer that transforms this into like a big structured search expression. So I don't know if you could really read this, but it says like, this is a test case from the source tree that says is pano actually expands to this, which is a search query with constraint. It's a logical constraint, union of this two sets, that it's a permanode, skipping boring ones, and it has a Camly content. The value of that Camly content has to be a blob ref that resolves to a file ref that is an image, and the width height ratio is a float constraint with a minimum 1.6. And so basically you can write these things too and do arbitrary searches. And we're kind of evolving the little cute short expression search stuff. I think we saw most of these tools. Oh, here's the most fun thing. So here's our Fuse file system. Let me make it bigger. So you can notice that if I look, we're currently on a Fuse file system. It's type Fuse. I made up these numbers and said that it's 64 terabytes, and I have 64 terabytes free. There's various directories in here. Like you can go into the @ directory and go in at various synthetic directories to go back in time to see things how were. So if you deleted something, you could just go back to @ and say @ 1 week ago or whatever. My favorite is the recent directory, which is a dynamic directory that's read-only, and it does a search query to find recent objects, recent permanodes that have appeared. So I can open this and say search by last modified, and this one and you can see the fuse thingies. Yep, and there's that photo. So here's the ones I took earlier this morning. FOSDEM. Faulting it back in from my house. Yay! So this is how I upload lots of my things to like Twitter and Google Plus and stuff. I have my phone set to auto upload, and I just go take pictures during the day, and if I wanted to put on G Plus or Twitter or whatever, I drag it over from this recent directory, which at my house is fast, and which from here is not as fast. But yeah, so got pictures from like, you know, the hacker thing party last night, and these ones are already cached on my machine because these chunks have been accessed more recently than the other photo. Yep. So you could do other search directories, but this is just a default one that comes out of the box, the recent one. You also have kind of like the roots directory, which you can go into here and, you know, okay. This is not fast when you're a long way away, I guess. But anyway, this is kind of like, you know, Dropbox mode, where you have a mutable file system that you can mess with. There's probably performance work to be done over high latency connections. Let's see. This is kind of the end, but we have a lot more demos. I just want to point out, I guess at this point, that everything you've seen is pure Go. It's a static Go binary. Actually, the thing that was uploading from here was just the cam put as a child process of the Java UI. And so it's actually cross-compiled to ARM on here. And all the server stuff was pure Go, including the HTTP and the TLS and the JSON XML, the WebSockets. There's an SMTP server also that's not integrated yet, but we're going to have it, you know, receive email because it has to. And rogues checksums, all the encryption, all the image decoding and resizing. The fuse file system is pure Go. And the database SQL package, along with lots of the stuff in the Go standard library, started out its life in Camlistore. If you actually look at the Camlistore commit history, you can see the database SQL package grew there and got moved. OpenPGP stuff. Actually, I have a good question. Who has actually contributed to Camlistore? I know we have a couple. So at least like 5 or 7. Who has contributed to Go? So yeah, I mean, like it's like half this room has code in this thing. The other cool thing, so I said we can import things from other places. I want to show, okay, we have that one photo in here. Let's put some more photos in there. Open this topic. Okay, let's take, I don't know, this picture, whatever. And here's our localhost web UI. We'll drag those over here. And that created permanodes that uploaded them and associated them. And now we want to kind of like say that, oh, this was a great vacation. Whoops, back to search. And we'll select all these guys. I don't know if it's visible at all. Bigger. Did I select that one? What? Oh, yeah. Okay. We just migrated this from Clojure to React, and there's probably some bugs. Anyway, we're going to create a set. We created a new set for that one, which is itself a new permanode. And if we actually go to inspect this, you see that there's 3 members in it. And if I said camtool describe, you would see that it's a permanode. It has a multi-valued Camly member attribute. So this is how you make an unordered set. And let's say I want to publish on the web. I could say, okay, access public. And this is like a debug UI. This will actually be sexier. Oh, I didn't start the server with let's awesome vacation. And so now if we describe it, you'll see that it has a title, awesome vacation, and those Camly member things. and we'll put it on a publish handler, let's say at /pix, and being like, live demo is awesome, and set URL. And so now, I'll show that one in a second. It created us a URL on the web at whatever /pix live demo is awesome, and we have like a little lightbox viewy thing. I mean, this was like my crap CSS or something. Somebody will make this pretty. But so this is how you can share it to the world. And the way you actually publish that is it made this claim here that says, let's make this bigger. It made a permanode with attributes camly path, live demo is awesome. So this is like the hop by a hop URL resolution that it was at this root called devpix root, and you could specify like what the name lookup per path is. And this itself is, this set that we were at before. So anyway, you can publish things on the web, but sometimes you don't want to publish things, publicly to everyone. So remember before we said we put that doc directory. Maybe I wanted to share this thing. This was just, directory of this stuff. I want to share it to like Andrew or something. So I say camput share, and I want to give it transitive all the stuff that's in it, and there's the top level. And it created a share claim, which now exists on my blob server and everywhere. And if I get it, it's of Camly type share, or somewhere. And the authentication type that someone has to have to get at this thing is havref, which is like the secret link, like the least access security model. This could be like, username and password, or TLS cert, or OpenID, or Facebook, or Twitter auth, or something like that. And this is the thing they have access to. And so now if I were actually to go and say curl, get that? It's unauthorized because I can't just get random blobs from the internet. But if I know this claim, I'm allowed to get the share claim because that one, I match the authentication type for this. And now I know that the next thing I'm allowed to get is that. So I can go back to the one that was denied before and say via that other one, whoops, which was this guy. And so you basically prove to the server why you have access to something, and then it's allowed to get it. Then I'm allowed to get this entries and recursively all the way down. So what you could eventually do then is, this was the top one. I could say camget -- shared and get that thing. Oops, shared. And maybe I'll write it out to desktop doc. Or I didn't have access to it. Well, whatever. Sometimes this demo works. It worked the other day. But it would put a directory on your desktop with all your stuff. Oh, that's why it didn't work. I already had the directory sitting there. But, yeah, so I've sent this to my friends for like, take a bunch of pictures over the weekend, and I send it to them, and they slurp it into their into their Camlistore server or into the file system. Andrew, did you want to talk about your CamTool Syncy thing, or do you want me to? Or?
Oh yeah, sure.
So as a little background, there's a CamTool sync subcommand, which you can sync from something to something else, blah, blah, blah. So you could do this to like sync from like your server to S3 or something if you don't have it configured to run in the background, which the default server does. But Andrew had a weird use case. So
yeah, so I actually live in two places separated by about 1,000 kilometers. And Australia is kind of a technological backwater. And so our interconnectivity is really poor. And so I have like something like, I don't know, a megabit upstream in both of my houses. Downstream's better. But when I go and take a bunch of photos and I put them in one Camlistore storage, I have two Camlistore stores, which should be in sync all the time. But if I go out and take photos with my DSLR, I might like create like a few gig of photos. And if I leave it sloping, it will just occupy all my upstream for a week. But I actually go back and forth between my houses every weekend. And so what I have is we added a third leg option to CamSync. And I keep a local, it's not actually a server, it's just a directory tree on my laptop. which has the right. The CamTool can treat a directory like a blob store, just a really naive blob store. And I can use third leg, and what it does is it will enumerate all the blobs in Sydney and all the blobs in the bush, and then, that sounds weird, and then it will compute the inverse intersection, whatever that is, the ones that are not present in the bush, and sync them to my third leg directory on my laptop. And I can just run this in a cron job, or I intend to write a little script that detects which place I'm in based on IP address or whatever. And then when I just open my laptop in the other house, it sees that I'm in the new place and then does the sync in the other way. And so I'm kind of doing the sneakernet myself, but it's fully automated. It's really nice and fast. And it was actually really easy to implement because Brad's code is really nice. I could just take inside CamTool, I could take, when you enumerate, you launch Go routines that do the enumeration, and then it sends all the blob refs on channels. And so I just like read all the blob refs off the channels, and then make a couple of maps. And actually, there's even a helper to do the intersection and whatever. Yeah. I don't know about. It's been a long time since I looked at the code, but it was really like adding 20 lines or something or less to the sync part to make that work. And so Brad's really, I mean, just a little advertisement. It's a great project to work on because Brad's just constantly like doing so much work, sort of gardening the code base and making things nicer. And so it's really just keeps improving. Great project. Thank you.
So, how are we doing on time? Yeah, it's probably a good time for questions, I guess. I probably forgot something in the demo, but that always happens. So.
Can you show up client-side encryption?
Oh yeah, let me go. So I'll start somewhere else and then get to your question in a second. So I mentioned that there's a lot of blob server targets. The question was about encryption. So here are some of the implementations of the blob server. There's this conditional one that can do conditional routing based on the content of the blob. Like, so you can say things like the metadata blobs go to SSDs, and the big blobs that are just raw JPEG data go to spinning magnetic disks. The disk packed one compresses things onto like a block device or a one big file. So if you have a file system, which is pretty much all file systems, they don't deal with tons of small files efficiently, you could concatenate them in one log and keep another side key value thing that has indexes into that big file. I'll skip encrypt for now. Local disk is the naive one. That's every blob is a file on the local disk. There's a namespace one where you can say that you can have dedupe storage between multiple users, but if one user uploads something, that adds it to their inventory that they have it, and if another user uploads the same one, now they have it, but they're sharing the same backend storage. So you can have dozens or hundreds of users or whatever that if they share photos amongst themselves and re-upload, you're not actually wasting any storage, but it's still isolated. The remote one is a client to another Camlistore server, just speaking the Camlistore client protocol. Replica one does replication between multiple blobs, and you can say, what are the write replicas, what are the read replicas, how many write replicas have to report success before you report success to the user. So you can say, I'm going to try to replicate to all these 4, but I'm happy if 3 succeed or whatever. S3 is Amazon S3. Shard does sharding, so you can make a kind of a tree of say blobs 0 through 7 go here and 8 through F go over here. Each one of those is maybe a client and is redundant in itself. Stats one does some stats. This is a testing framework for all these other types. But one of the fun ones is a lot of these things are actually conditional is composed of other ones. So you can say on condition go to this storage target, on otherwise go to this one. This is all something you just write in the config file. Likewise with remote and replica and shard, you're just always referencing other existing storage targets. So any of these can kind of be plugged into the other ones. But the fun one is encrypt, where you basically can encrypt all your stuff on top of any one of these other ones. So you can say encrypted on S3 or encrypted to this remote one. And so your friend is running a Camlistore server and you are too, but they store your blobs, but they don't really know what they are because you're encrypting it on your side before you even send it to them. And then decrypts it on your machine later. So I don't know if I answered your question at all. Close enough. Any other questions?
Can you talk about the contribution process?
Yes. The question was contribution process. Camlistore.org has some kind of docs and videos, and one of the docs is contributing. We require you to do a CLA, just like most responsible projects, and we use Garrett, and there's basically docs here. The hacking file at the root says how to do it, and sometimes people come out of nowhere and start contributing really awesome code, like Mr. Dude in the front here, Solomon. I think you might have just followed the directions one day and didn't. Some people send you a pull request on GitHub, and we don't currently use GitHub because their code review sucks. But we're thinking about maybe starting to accept GitHub pull requests, but then writing a bot that monitors it and turns it into a Garrett code review and comments on the pull review and said, okay, go fix your code over here. When it's done, I don't know, maybe sync back to the pull request on GitHub. But so yeah, that's the contribution process. It's really easy to get started. Building the whole thing, you can use just go get and go install. Like you can say go get camlistore.org, server camlistore.d. Or likewise, come to cam get, or come cam put, whatever. Or you could just go and type make, and we have this tiny make file that basically just runs go run make.go. So this whole thing should run on all the tests pass on like Linux and Mac, and we try to not make releases that are broken on Windows, but some parts are now missing on Windows. The Fuse stuff kind of worked once on Windows, but now it is bit rot for a couple years. So if you actually care about Windows, you could help, but I doubt this audience would.
We basically repair it every time we have to do a release.
Yeah.
Is this being used at Google at all? Or?
No, it's not being used at Google. Well, maybe by a lot of Googlers contribute to it, but I just did it because I wanted it to exist.
The 20% project or just on expression?
Yeah, I don't no one counts hours in 20% time or counts the minutes. When I did this first because I was working on the Android team, and building Android requires this $11,000 workstation, and it takes an hour to build. So if you're sitting on a bus between Mountain View and San Francisco, which I unfortunately had to do at the time, that was 2 hours of my life wasted a day with a crap internet connection and a laptop. And so I wanted to work on this, but I didn't want to write it in a scripting language because I knew it would be painful in a scripting language. I didn't want to write it in C++ because C++ makes everything painful. And Go was kind of just coming out at the time. And so I said, okay, I'm skeptical, whatever, a new language, whatever. And so I figured I would get started and build a prototype, and then it just it exploded, and I loved Go. And so I was working on it so much and sending so many patches to the standard library that Rob Pike said, hey, you want to come work on Go full time? And it was so much more fun to write in Go than write in Java. And I thought Android was doing fine, so they didn't really need me. So then Rob Pike said I could actually work on this, 100% if I want, because he's apparently as much as you hack on Camlistore, it benefits Go somehow, so just have fun. So I try to hack on it more than 20%, but in practice it's 5%, 10%. Some weeks I work on it a lot, and then I feel guilty that I'm not working, but I guess it's kind of work. But
so given that you have this content-addressed tree system, will you self-host at some point stuff as you get?
Yeah, the question is, can we just use Camlistore instead of Git for our source code? It could, but it's it's a distraction. Then we're Bazaar or something like that, right? And people are want to contribute to your project, but you use Bazaar. So whatever. Git is fine. Git is really fast for what it needs to do. They've optimized the lookups and what system calls they do to be really fast, and they index stuff on disk to have all the deltas in a row. And so, you could put a Git repo on it, and we could speak the Git protocol, but we probably wouldn't. It's more likely we would have a self-hosted Git repo, and we would just speak the Git protocol on one side and store it on Camlistore on the back end. But we wouldn't store it as efficiently, and maybe not as quickly. But it would be a cute hack, but I don't know how useful it would be.
You mentioned that normal users would probably use a hosted version.
Yeah.
Is there such a hosted version?
Yeah, the question about is there a hosted version of this yet? No, not yet. I'm working on one right now for my friends and family because my brother and my dad have been bugging me a lot about backing up to my server, and I've given them little scripts that they can run on Windows or whatever that run rsync and run stuff, but I want them to be using my stuff. So they said, we'll use it if you set it up for us. So I've been setting up, and then a bunch of my friends want to use it too. So I'll put that somewhere, and then hopefully somebody else can run one, or other people can run a self. It's pretty easy to run for yourself, but if you want to run one for your like own friends and family, it'll be easier soon. I'm adding Glacier support right now too. So when an incoming blob comes in, what I'll do is both write it to my local disk and write it to S3 synchronously before I report to the client. And because uploads to S3, the incoming bandwidth is free, that's fine. But I'll have it on my machine, and once I get like a meg or 50 meg or something of stuff that's on S3, I'll write one big Glacier archive, which is also free because like incoming bandwidth. And then I'll delete the S3 objects that I don't need, that 1 meg or 50 meg buffer, and delete operations on S3 are free. So basically I'll use S3 as kind of like a little buffer where all I do is upload and delete, and I never do a fetch. And so then it'll be cheap and efficient, and so I won't lose my friends and family's data. So I'll publish that whole configuration soonish. The question is, what is the blow up factor with all the metadata blobs? It's not much. I mean, I don't think anyone should use the file per blob thing. It's kind of just for development. But the disk packed one is good. And the blow up is very minimal with that. There's like little JSON here and there to say like this is a leaf of the tree, but compared to the JPEG itself, it's noise. And it compresses really well. Yeah, so we are going to do IMAP import and preserve all your tree structure and your labels and stuff, so you'll have like perfect fidelity copy of your Gmail or whatever. And then we also have an SMTP server that I wrote in Go that's pluggable, and so we'll actually let you accept mail directly into it. And then we might have an IMAP server that uses this as the backend and to do all to answer the IMAP questions. So. Somebody else wrote a MP3 music player. So what we want to do is we're going to try to remove all this crap from the core and turn all this stuff into applications. So the core would just speak like the search protocol and the blobs, and the web UI, the Fuse stuff, I mean, those are already basically separate apps, client apps. But my friend made a music player, and he keeps all the play history and all the stuff in Camlistore, and he has his own UI on top of it. It is not yet full text indexed. There is a plan of sorts, but it's kind of a low priority. Feel free to add it.
Is the index on the client and on the Android application, for example?
No, there's no index or search on the client app. You can do like, you'll be able to do a search from it and like, see all the stuff, but it's not actually running the indexer there. There's no reason it shouldn't work, but it would be.
Where does the indexer typically run?
The indexer runs like wherever. Well, you can actually run them on separate places, or you can run the default configuration. It runs it in the same process. The blob server and the search and the index all run together, but you can separate it. You can say this machine is only the blob server, and this one over here is only the index, and that guy over there is only the search.
So just relying on S3 isn't sufficient because S3 presumably can't be the index.
Yeah. So in that page where I said that there's like 2 main abstractions, you need to provide one of each at minimum. You need to provide the blob. I don't know where it was.
Stop scrolling.
You're getting sick? Whatever. Okay, so there's 2 things. There's the blob storage interface that you have to provide for blob storage, and then there's the sorted.keyValue that you have to provide for the indexer. And that could be anything you want. So I use MySQL because I just have lots of MySQL experience. A lot of people use SQLite or Mongo or LevelDB or whatever. The one that ships out of the box is a pure Go key value store. And so you don't need any server to run the indexer. It's just a file on disk. So maybe one more? Or not? All right. Have fun. Let me know if you find both. Is there one? Oh, all right. Question was priorities. If search is near the bottom, what is near the top? Or a full text search is near the bottom of the list. I think I'm I'm doing anything that I'm trying to fix anything that I'm blocking other people on doing things for. So people doing the web UI and making it sexy, I'm trying to not stall them so they don't get bored, because I don't like doing JavaScript and CSS and stuff. So if there's other people eagerly doing that, I'm going to keep them happy. So I've been working on search a lot, but search is kind of in a good state now. So I'm working on that. I think the main thing I'm doing right now is the multi-tenant hosted version. So like the namespace support I just did, working on Glacier. We're actually going to run every user for now in their own Docker container. And so there'll be a front-end load balancer that fires up Docker instances on demand, either light ones without the search index, or if they're just uploading a blob, it'll start a really fast server. And if it has a full index, then it like slurps it into RAM, all the metadata for search. So all those mechanisms to make a hosted version is kind of what I'm doing now. But it's really like somebody comes on the mailing list and sends a patch, and then my priorities all change because like they found something that was broken and it's stalling them, and then I like go fix the broken thing. So
What does the new hotness link do?
the new hotness.
It goes to the UI you showed.
Oh,
It's a work
yeah.
in progress, and so sometimes we go back to the old UI, and we have
Yeah.
functionalities in the old UI, and none of them. Some of them are not in the new UI.
Yeah. So this is the new hotness, which isn't that hot, but you know we can press left and right and go through the search query, and you see the piggy walks in the right direction. But and this won't be metadata. This will be like, you know, maybe exit, focal distance, and retagging and title, and let you change stuff. But the old and busted was this kind of debug page. Oh, this is where, you know, I could add tags, and I could publish it, and I could see dumps of things and change the title and view the raw blob, whatever. So I made this for me just so I can click around and give demos and explain the data model to people, but it's not really a good user experience. So the new hotness, you get a big picture. Somehow. This does not demo well from California to here. Out of my garage. Oh, it's missing like a new UI parameter. We just changed all this. Like I think you have to say new UI equals 1 or something like that. I don't know. Whatever. Oh, so the UI is a big priority, but just not for me. All right, cool. Well, I'm out of time, but feel free to join the mailing list. It's increasingly fun and active. So thank you.